A group allows a logical collection of users so that they can have similar access to files and folders. Groups are used for group ownership of every file within our operating system and then allows for the assessment of access based on the permissions set at a group level. Each group has a human-readable name that we use to interact with it, but always maps to a group identification number, or GID, in the same way that we saw users map to their user IDs. The operating system itself will actually keep track of group ownership, and group membership via these GID numbers. By default, the system will use the file located in etc group to store this information. Here is some sample output from the etc group file. This is an extracted single line from the entries in etc group. Let's take a look at what all the values mean for each of these fields. First, we see group 01. This is the group name. Many groups exist within the etc group file itself, and each one has all of the rest of its characteristics described in its entry. Field 2 is an obsolete field that included a group password. If group passwords are enabled and utilized, that information is now stored elsewhere. Originally, this would have been stored in plain text here, but we understand now the security implications of keeping and managing data in this way. The next field is the group identification number, or GID, here shown as 10,000. The GID number, remember, is how the operating system actually keeps track of groups, group membership, and group permissions. Lastly, field 4 lists all the users who've been added to this group. This is members who've added this group as a supplementary group. We saw in the user identification area of etc password that a primary group is assigned to each user. Group membership, done in that fashion through the UID's primary group, is not going to show up as a list here. Only membership in supplementary groups are shown in this fashion. Here, we know user 01's primary group was a different group, namely GID 1000. This group, group 01, is a secondary or supplementary group for that user, and therefore the user shows up as an added member to this group. In this section, we'll explore gaining super user access. Once we're done, you should feel comfortable being able to use the sudo or sudo command. This will allow you to access the privileges of the super user from a normal user account. First, let's discuss the super user. Most operating systems have some concept of an administrative or full access user account. In Linux, we call this the super user, and by default, that username is root, R-O-O-T. The root user has full access to the entire operating system and can override the changes of any other user. It's important when you create Linux accounts to know that this user exists for both the senior administrative tasks required throughout the operating system, as well as to understand the powers granted when someone has access to this account. The root user account should be reserved for only administrative purposes, and being able to access this account should be reserved for only people who need that access. Root passwords should be set and secured in the highest of fashion. Many administrative tasks that we do on a routine daily basis do require this type of access. Installing or altering software, adding or removing USB hard drives, as well as many other just files and configuration settings throughout the operating system will require these elevated privileges. It's not uncommon to use the root account for many of the work you'll do in Linux. However, with great power comes great responsibility. Be sure to secure this account with strong passwords and limit who has access to the account to only those who will perform those elevated responsibilities. If you're coming from a Microsoft world, the root user account and super user privileges in Linux are akin to the administrator account within a Microsoft Windows environment.